Well, the other effect of sulfur dioxide, the reason because it uses technology, is to protect against spoilage microorganisms. In that sense, the first authorized product was evidently Lysozyme. Lysozyme is a very good antiseptic for gram-positive bacteria, especially lactic acid bacteria. This is an example of what happens in a wine in which Lysozyme was added at a dose of 25 grams by hectoliter. It is clear that the presence of lactic acid bacteria decreases a lot and it's completely disappeared. Well, Lysozyme is very useful, yes, but it has a problem. It's very expensive. And after, if you use Lysozyme, you need to indicate in the label because many people can be allergic to this product. In any case, can be used to avoid and to prevent malolactic fermentation, but with some rules. Well, another possibility is the use of Chitosan. Chitosan is a polysaccharide that is extracted from the fungi, and that is very useful for inhibiting some microorganisms, especially Brettanomyces. That is an example of what happened adding 0, the control, 2, 4, and 8 grams by hectoliter on the population of Brettanomyces. You can see that the higher is the dose of Chitosan, the lower is the population. And that is what happens in the scanning electron microscope. We can see that the healthy Brettanomyces with adding Chitosan and what happens in the external aspect when we add this Chitosan. You can see that really the cells are affected. And that is the reason because Chitosan can be useful to prevent the development of Brettanomyces species. Wow, yeah. More recently, fumaric acid, transbutanoic acid, it is proposed as an inhibitor of malolactic fermentation, lactic acid bacteria. It's not authorized now, but probably it will be authorized before the end of this year by the OEB. Fumaric acid is an intermediary of Krebs cycle and is also authorized as additive in other foods and is used widely in wine food industry. Well, that is results that are made by our research group in base wines for elaboration of sparkling wines, cava. Well, that is what happened when we add 6 grams by hectoliter of sulfites, that is high dose, you can see. That is what happens with malic acid and what happens with the population of lactic acid bacteria. This experience was made with the control wine and also adding, inoculating 10 exponential 5 colony unit formation units of Oenococcus oeni, previously isolated from bottles of sparkling wine that have developed malolactic fermentation. You can see that in the case of 6 grams by hectoliter of sulfites, the control malic acid remains constant, and we can see a small development at the end of the process of some lactic acid bacteria. But in the case of the wine that were inoculated with lactic acid bacteria, it is clear that malolactic fermentation starts and that lactic acid bacteria really has. Well, what happens when you reduce the dose of sulfites? In that case, 3 grams per hectoliter. In that case, it's clear that the wine inoculated with lactic acid bacteria completely performs malolactic fermentation in 60 days. And we can see that lactic acid bacteria start to develop and reach high population at 20-25 days. Well, what happens when we add fumaric acid? In that case, a very low dose, 0.3 grams by liter.